Welcome to Manifested Publishers.
Hello, learner. My name is Dickens Mugalo, and I welcome you to today's lesson. In our lesson, we are going to discuss the chemical properties of alkanes. We have already seen the physical properties, so it's time we now look at the chemical properties. We are going to look at two main chemical properties. The first chemical property is combustion. So we start with combustion. 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 This is to do with burning. So we need to know this, that alkanes burn in air with a pale blue flame. That is the main distinction property, that alkanes burn in air with a pale blue flame. To produce, we get two products. To produce carbon dioxide, and water. So these products are only possible if we use excess air. But if limited amount of oxygen is used, then instead of getting carbon dioxide, we get carbon oxide. So we are saying in limited supply of oxygen, carbon oxide is formed. So, but under normal circumstances, that is in plenty supply of oxygen, we are saying all alkanes will burn in air with a pale blue flame to produce carbon dioxide and water. So I would like us to look at examples of combustion of alkanes. So the first one, we start with the first member of alkane series, which is methane. So methane undergoes combustion under ordinary conditions, that is in plenty supply of oxygen. We get carbon dioxide gas and water. So what is key as far as such equations are concerned is balancing. And I want to advise you that if you're balancing any equation in organic chemistry, you start by balancing the number of carbon atoms, and then you balance hydrogen atoms, and then you finish by oxygen. One good thing about organic chemistry is that you are allowed to use fractions to balance chemical equations. So having said that, I would like us to use that concept to balance this equation. So you can see we start by carbon, we have already said, so we have one atom of carbon on the left and one atom of carbon on the right. The next thing you check is hydrogen atoms. Here we have 4, that is on the left. On the right, there are 2. So to make this one 4, we multiply this one by 2. That means I'll have 4 hydrogens on the right. Lastly, you check oxygen. Here we have 2 atoms. This side has 2 plus 2, that will give you 4. So the left has 4 oxygen, the right has 2. So to make them to balance, I multiply this one by 2, like that. So the equation is balanced. Another example is ethane. The formula C2H6 burns in oxygen to give you carbon dioxide gas and water. So I've already said the key thing here is balancing, and we have said the best way is you start balancing carbon, and then next you move to hydrogen, and then you finish with oxygen. So let's start with the carbon. The left hand side has 2 atoms of carbon, the right hand side has 1. So to make this one 2, you multiply here by 2. Then next you check hydrogen. This side has 6, so this side has 2. So to make this side to have 6, I'll multiply by 3. That will make the number of oxygen atoms on the right hand side to be 4 times 2, that is 2 times 2, that is 4, plus 3, that will give you 7. So this side has 7 oxygen atoms, while this side has 2. So I need to make this side to have 7 oxygen atoms. So I will do is I'll multiply these 2 by a fraction that will give me 7. And that fraction is 7 over 2. So 7 over 2 multiplied by 2, you'll get 7. So we have used a fraction. So I've already said in organic chemistry, you are allowed to use fractions in balancing equations. The third example is propane, that is C3H8 and oxygen reacting. That will give you products the same, carbon dioxide gas and water. And remember, we have said burning of alkanes in oxygen will be seen by production of a pale blue flame. We shall see the next class, alkenes and alkynes. The flame is not pale blue, so we shall see the color when time comes. Balancing, we start by carbon. So you have 3 atoms of carbon on this side, then this side has 1. So to balance, I put here 3, I multiply by 3. Come to hydrogen, I'm having 8, this side has 2, so I multiply this one by 4 to make it 8. That will mean oxygen atoms on the right hand side are 2 times 3, 6, plus 4, that is 10. So to make this side to have 10, I multiply by 5. So that equation is balanced. We look at another one more. Butane, that is C4H10, reacting with oxygen, that is combustion. That will give you carbon dioxide gas and water. Once again, we balance together. 4 atoms of hydrogen, this side has carbon, this side has 1, so I multiply by 4. Then come to hydrogen, this side has 10, this side has 2, so to make it 10, I multiply by 5. Then you finish with oxygen. This side has 4 times 2, this is 8, plus 5, that will give you 13. So I need to make the left hand side to have 13. So I will multiply this one by a fraction, and that fraction is 13 over 2. So 13 over 2 times 2 will give you 13. The equation will have balance. So we look at one more. Pentane, C5H12 plus oxygen gas, that will give you CO2 gas and water. Balancing, remember, you start by carbon. So this side I'll make this one by 5. Hydrogen, this is 12. To multiply the right hand side by 6 to make it 12. Then you finish by oxygen. This is 5 times 2, 10. Then plus 6, that is 16. So I multiply here by 8 to make it 16. So that is how we balance such equations. So we have said the best way is you start by balancing carbon, then followed by hydrogen, and then you finish with oxygen. So the key concept here is alkanes burn in air with a pale blue flame. So that is the first chemical property that I wanted us to look at. The next chemical property is called substitution. Substitution reactions. Substitution reactions. From the word substitution, we get the word substitute. And substitute means to replace or to take the place of. So substitution reactions are simply reactions in which an atom or a group of atoms are replaced by another atom or by another group of atoms. So we start by defining substitution. Are reactions in which one atom or a group of atoms in a molecule is replaced by another. So the keyword is replacing. So to substitute means to replace or to take the place of another one. So alkanes are able to undergo substitution reactions, and this one mostly happens with halogens. We know very well halogens are members of group 7. So alkanes are able to react with the halogens, and the reaction can only take place in the presence of sunlight or UV light. And the main purpose of the UV light is simply to break down the halogen molecule into atoms. So substitution reactions of alkanes with halogens takes place in the presence of sunlight, which is also called UV light. And we have said the main use of the UV light is to break down the molecule. Remember, halogens exist in form of molecules. So the light will break down the molecules into atoms. And those atoms are the ones which will be able to undergo substitution with alkanes. So the light breaks down the halogen molecules into atoms. So it means in the absence of light, then no substitution reaction can take place in alkanes. But in the presence of sunlight, the reaction is possible. And we need to know that this substitution takes place in stages until all, remember you are replacing the hydrogen atoms in an alkane. So the reaction takes place until all the hydrogen atoms have been substituted. So it occurs in 4 steps. So we want to look at an example of a substitution reaction that involves methane and chlorine. So example. So first example is substitution of reaction of methane with chlorine. So I have already said the reaction occurs in 4 steps. So we shall go step by step. And remember, anytime you are looking at the reaction, it's advisable you draw the open structure so that you can see which atoms are being replaced. So we know from the structure of methane, we have 1 carbon atom surrounded by 4 hydrogen atoms. So this is methane. Reacting with chlorine. Remember, chlorine gas is a molecule, and that molecule has 2 atoms. Those atoms are bonded by a covalent bond, as you can see here. So that is the illustration. We have 2. The 2 constitute a chlorine molecule. So this reaction occurs in the presence of UV light. So the substitution, we have already said it occurs in steps. So we are going to substitute each atom of hydrogen 1 at a go until all of them are substituted. So we start by this one here. So we shall draw the methane with the 4 bonds. Then you put the hydrogen atoms, and then this hydrogen atom is going to be substituted with 1 chlorine atom. So this chlorine will take the place of this hydrogen. So instead of H, the product will have a chlorine here. So what has happened? This hydrogen has been substituted with a chlorine. And then we shall be left with 1 chlorine atom. This 1 chlorine atom will combine with this hydrogen. Then we shall form another product. And that other product is called hydrogen chloride. So we have 2 products. We have one having carbon with 3 hydrogens and 1 chlorine, and the other one having HCl. So the name As we saw from branched alkanes, this one is called chloromethane. This one is called chloromethane because it has one atom of chlorine attached to the first carbon atom, the first and the only carbon atom of methane. Therefore, the name is chloromethane. So that is the first step. The second step is that this chloromethane undergoes further substitution. It undergoes further substitution as follows. So we have this. This is chloromethane. Chloromethane undergoes further substitution. Remember, the reaction is occurring in the presence of UV light. We have said the main purpose of the UV light is to break down the molecule into atoms. So these are already atoms. So this hydrogen here will be substituted with one chlorine. So we are going to have carbon with the initial chlorine, then the initial hydrogen, and this one. And then this hydrogen is going to be substituted by one chlorine atom, like this. So we shall have that. And then plus, this hydrogen will combine with the remaining chlorine atom. We shall get another product, which is hydrogen chloride. So we get this new product that has two chlorine atoms. The two chlorine atoms are attached on the first and the only carbon atom. Therefore, the name of this compound will be, now that there are two, we shall use the word di to mean two, and then chloromethane. So this one is called dichloromethane. Di means two. So we have two atoms of chlorine attached to one carbon atom. This dichloromethane undergoes further substitution in the third step, reacting with more chlorine, of course, in the presence of sunlight or UV light. And once again, the light will break down the molecule. Remember, initially it is chlorine gas, but because of the light, this chlorine gas or molecule will break down into two atoms, which are illustrated in the equation for easy understanding. Further substitution, one more hydrogen will be substituted by one chlorine atom. So we shall have this product here. So we shall be left with one hydrogen, and then plus this hydrogen will combine with the remaining chlorine atom. We shall form this compound, hydrogen chloride. So the new product has three chlorine atoms which are identical with one hydrogen, all of them bonded to one carbon. Therefore, because we have three chlorine atoms which are identical, we shall use, from di, we shall use tri, meaning three. So this is going to be called trichloromethane. Trichloromethane. That is the name of that compound. Remember, we have said the substitution reaction takes place until all of the chlorine atoms, or until all the hydrogen atoms have been substituted. So this one undergoes further substitution. So this will be carbon, that is trichloromethane, undergoing further substitution, obviously in the presence of UV light, to give you a new compound. So this remaining hydrogen will be substituted by one chlorine atom. So we shall get this chlorine, 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 and then this H will be replaced by a chlorine, and then plus, remember, this hydrogen will combine with the remaining chlorine. We shall get this compound here that is called hydrogen chloride. So the new compound that has one carbon bonded to four chlorine atoms, that compound is going to be called tetra. Tetra means four. So tetrachloromethane. So you can see, learner, that the reaction has occurred until all of the hydrogen atoms have been substituted. So it occurs in steps. So that is the substitution as far as methane is concerned. We can look at also substitution reaction to do with the methane reacting with the bromine. Then we shall compare the two. So my second example of substitution involves substitution reaction, or the reaction between methane as well as bromine gas. Remember, bromine is also a halogen, and we know very well halogens have, each halogen molecule has 2 atoms. So second is substitution reactions, substitution reaction of methane with bromine. The reaction also occurs in 4 steps. So the first step is, remember I've said the best way is you draw the open structure. It's easier to visualize the substitution of the atoms, easier when we have drawn the open structure. So this is methane combining with bromine. Remember, these are 2 atoms of bromine which are derived from bromine gas, which is Br2. So because of the light, these 2 atoms or this molecule will be broken down by the UV light to give you 2 bromine atoms which are bonded like that. So substitution occurs just like a chlorine. So each hydrogen is substituted one at a go. So first one is the first hydrogen is substituted by a bromine. So we have substituted the first hydrogen, the one on the extreme right. Then this hydrogen will combine with the remaining bromine. We shall get this product, which is called hydrogen bromide. This one contains a bromine bonded to 3 other hydrogens on carbon. Therefore, the name of this compound will be called bromomethane. Bromomethane. Bromo from bromine. So we don't write the whole word, but we did the bromo part. Then second step is this bromomethane undergoes further substitution, obviously in the presence of UV light, to give you. So this hydrogen will be replaced by a bromine. So we shall get hydrogen. We have bromine, another bromine up there, then hydrogen plus hydrogen bromide. Now this compound, dear student, has 2 bromine atoms. So if there are 2 and they are identical, we introduce the prefix di. So this will be called dibromomethane. Dibromomethane. So that is the name of that compound. So dibromomethane undergoes further substitution. So it is dibromomethane undergoing further substitution in the presence of UV light. Remember, we have said the light, the main purpose is to break down the molecule into atoms. The other hydrogen will be replaced. So we are going to have Br, carbon, bromine, and 1 hydrogen plus the other product, HBr. This hydrogen will combine with the remaining bromine to give you hydrogen bromide. The name of this compound that has 3 bromine atoms which are identical. From the word, the fact that there are 3, then we now introduce the prefix tri. So this will be called tribromomethane. Tribromomethane. Then the last step, tribromomethane undergoes further substitution. It undergoes further substitution in the presence of UV light. Remember, we have said the UV light will break down the bromine molecule into bromine atoms, the ones you are seeing here. So these are the bromine atoms. So we shall realize that all the hydrogen atoms will be substituted. At the end of the day, we shall have a new compound that has all bromine atoms and the other. So this hydrogen will be substituted by a bromine. Then this hydrogen combined with the remaining bromine, we get hydrogen bromide. So we have a new compound that has 4 bromine atoms. So that compound is called tetrabromomethane. Tetrabromomethane. So that is how substitution occurs in alkanes. You can still look at substitution of methane with chlorine. Not really chlorine, but iodine. Now, I want us to notice this, that the speed of the reaction differs from one halogen to another. In that, if you compare the rate of reaction, the substitution between methane and chlorine, the reaction is faster than the substitution reaction involving methane and bromine. Of course, the reason is simple, that from the knowledge we learned in Form 2 under halogens, the reactivity of halogens decreases down the group. So for that reason, we expect the reaction between chlorine and methane to be faster than the reaction between methane and chlorine. So that is the difference. So I'm saying methane and chlorine, the reaction is faster, but methane and bromine, the reaction is slower. If you also look at iodine, the reaction is also more slower, because out of the 3, iodine is the least reactive of the 3. So that is that. To wind up that part, I would like us to mention the uses of alkanes. We mention uses of alkanes so that in case someone asks you, you should be able to answer such a question when it comes your way. So, uses of alkanes. Remember, we have been talking about alkanes, and we have said alkanes are hydrocarbons that have a general formula of CnH2n plus 2. We have talked about preparation, whereby we have said alkanes are generally prepared by the reaction between soda lime and the corresponding sodium alkanoate. For example, if you want to prepare methane, you simply react sodium hydroxide and sodium ethanoate. If you want to prepare propane, you react sodium hydroxide and sodium butanoate. So the salt will have more carbon atoms. Then we have looked at properties, physical and chemical. Physical, we mentioned boiling point, melting point. We saw the melting and boiling point increases as the number of carbon atoms increases. Under chemical properties, we have looked at combustion. We have said anytime an alkane is burnt in air, we shall get carbon dioxide and water. So you should be able to balance any equation that comes your way. So we wind up by looking at the uses of alkanes. First one is this, that alkanes such as methane, methane and propane are used in homes as fuels. So I believe that one, at least we are aware, those gas cylinders we use at home, they contain methane. So they provide fuel for domestic purposes. Use number 2 is that they are used in the manufacture of carbon black. We have a compound called carbon black, which is a component which is a component of printers ink. So another main use is manufacture of carbon black, which is used, of course, in the printer's ink. The third use is they are used in the manufacture of methanol. We shall see methanol under organic chemistry too. That one belongs to a class of alcohols. So used in the manufacture of methanol and methanol, which are useful industrial chemicals. And lastly, the last use is they are sources of hydrogen from cracking. Remember, we said cracking involves breaking of long chain alkanes to produce small chain alkenes and hydrogen. So we can still get hydrogen for use in processes such as the Haber process. So we get that hydrogen from cracking of alkanes. So we wind up by looking at the questions. So questions for your revision. The first question I would like you to attempt is write balanced chemical equations for the combustion of the following alkanes. So write balanced chemical equation for the combustion of the following. The first one is pentane. You write the equation for the products of combustion. The second one is hexane. Try and write the equation. Then the last one is heptane. So you should know the products. We have already said the products are two: carbon dioxide and water. Second question is define substitution reactions. Define substitution reactions. Then third question is write equations to show the substitution reactions between methane and iodine. So you write equations to show how methane and iodine react as far as substitution is concerned. So we have come to the end of our lesson, my dear student. So what you have learned generally about alkanes is that alkanes have a general formula of CnH2n plus 2. We have looked at the physical properties. We have said the physical property basically depends on the number of carbon atoms. We have looked at chemical properties, where we have said they undergo combustion to produce carbon dioxide and water. They undergo substitution, and the reaction requires the presence of sunlight for that reaction to take place. And then we have also looked at the way alkanes are used. We have seen we have 4 uses of alkanes. So otherwise, I want to thank you for being a good student, and I will see you in the next lesson. Thank you.